So class question 1a, we are given figure 1.1. So the net electric field strength at point A due to charge P and Q is 1.37 to the power of 7 Newton per coulomb with the direction 65.8 degree below the horizontal. So charge P is 5 microcoulomb. So charge P is a positive charge of 5 microcoulomb at the position as shown in the figure. So charge P is 6 cm from point A. So charge Q is 8 cm from point A, but the question didn't draw us the positions of charge Q. It only tells us that charge Q is 8 cm from point A. So question 1. With the help of an electric field diagram, determine the magnitude and the type of charge Q. So we want to determine what is the magnitude of charge Q and also the type of charge Q. Means that charge Q is positive charge or negative charge. So we need to draw the electric field diagram in order to solve the questions. So I recopy the figure. Okay, so we can say obviously the net electric field at point A, which act at an angle 65.8 degree, actually we can resolve into two components. We can resolve it into two components, which is component X, X, and also component Y. Okay, so after we resolve the component, resolve the E net to these two components, we can see obviously the EY actually is the electric field created by charge P. Okay, the E component Y actually is the electric field created by charge P. Because charge P is positive 5 microcoulomb, charge positive, it will have electric field line that outward from the charge, so it will be pointing downwards. That's why we can see obviously the component Y of the electric field at point A is due to charge P. So it means that the EX, the component X of the net electric field at point A will be due to the charge Q. Because the question tells you the net electric field strength at point A is due to charge P and charge Q. So the electric field created by charge Q is pointing to the right. So we might assume we have the charge Q here. So this is our charge Q, whereby the distance of the charge Q from point A is 8 cm. So class, when I put my charge Q here, I can see obviously my electric field vector is point into the charge. So the type of charge, then I might say that the type of charge Q will be negative. According to the electric field diagram I draw. Okay, then I want to determine what is the magnitude of charge Q. So we understood that the component X for the net electric field is the electric field due to charge Q. So this component X of the net electric field is adjacent to the angle. So we can determine the component X by taking 1.37 to the power of 7 multiplied cos 65.8 degree. So this will equal to the electric field due to charge Q. So the equation to calculate electric field due to the point charge Q is given by equation 3 KQ over R squared. So the K is the proportionality constant. You can get it from the list of constant, 9 to the power of 9. So then the magnitude charge of charge Q over the distance. So the distance of charge Q from point A is 8 centimeter. Change it to meter times 10 negative 2. Then square, R square, R square. So when we do our calculation, we will get the magnitude of charge Q is around 4 to the power of negative 6 coulomb. Then question 2. If the type of charge Q changes, but its magnitude and position remain unchanged, does the electric field change or remain the same? Explain your answer. So class, the question asks if I change the type of charge Q. Okay, I redraw the diagram. Let's say I change the charge Q. So I draw it here. So let's say this is the charge Q. Okay, this is our charge Q. Then now we change the type of charge. So just now I said my answer, the charge Q is negative. So now I change it to positive. I change it to positive charge. I change the type of charge Q, but the magnitude remain the same. The magnitude remain the same. The position remain the same. It's still 8 centimeter from point A. So the question asks, does the electric field will change or remain the same? Boys and girls, since the type of charge now changed to positive, so now we will find out that the electric field created by charge Q will pointing leftward. It will pointing leftwards. And then the electric field created by charge P is still pointing downwards. So now we will find out that the net electric field created due to the charge Q and also charge P will change direction. Now the net electric field will point in another direction. Okay, so now this will be our net electric field. So we will find out that the electric field will change. So we will find out that the directions of net electric field changes. But how about the magnitude? Is it still remain at 1.37 to the power of 7? Yes, the magnitude of net electric field is unchanged. So the magnitude, nilai untuk net electric field ni tidak berubah. Why? Because the magnitude and the position of the charge Q is remain unchanged. Because the magnitude and position of charge Q is unchanged. So they still give the same magnitude of electric field, but then the direction change because the type of charge change. So this one will be our answer for question 2. Then we move on to question B. We are given figure 1.2 showing two opposite charge metal plate P and Q separate by 2 cm. So the separation between the plate is 2 cm. So an electron is released from rest at plate P. So initially the speed of the electron is 0, is initially at rest. Then we release it and it reaches the speed of 5.13 to the power of 6 meter per second just before it strikes plate Q. So when it strikes on plate Q, its final velocity will be 5.13 to the power of 6 meter per second. So assume no gravitational force act on the electron. So the gravitational force refers to the weight. So we can ignore the weight. There will be no weight acting on the electron because the mass of the electron is too small. So question 1, sketch the path of the electron motion between the plates. So we want to sketch the motion path for this electron. So the electron will do the straight line motion or projectile motion. So kita nak sketchkan path of motion. Second one, determine the electric force acting on the electron. So we want to find F, the electric force acting on the electrons. Okay, so how we are going to know what is the path of motion for this electron? First, we have to identify the direction of the electric force acting on the electron. So electron is negatively charged. So for this electron, it will experience an electric force pointing towards plate Q. Okay, so it will have an electric force pointing leftwards towards plate Q. So due to this electric force leftwards, so it will move straight horizontally and strike on plate Q. So this is the path of motion. This is the path of motion. Means the electron will move in a straight horizontal line due to the leftwards electric force. Okay, it's because of the electric force acting leftwards, so the electron will move in a straight horizontal line towards plate Q. Okay, then second questions, we want to determine the electric force acting on the electron. So the electric force, due to this electric force, we can see obviously, because of this electric force, the electron will move from rest and reach a speed of 5.13 to the power of 6 meter per second when it strikes on plate Q. So it experiences an acceleration. Okay, this electron experiences an acceleration A due to the electric force. So I can determine the electric force by applying Newton's second law. So when I apply Newton's second law, summation force equal to ma. So the only force acting on the electron is the electric force. So electric force equal to ma. So I can determine the electric force by substitute the mass of the electron and the acceleration of the electron. So I can determine the acceleration of the electron from the change of the speed. So the speed change from 0 to 5.13 to the power of 6 meter per second when the electron travels a distance of 2 cm from plate P to plate Q. So our distance travel is 2 cm, 2 to the power of -2 meter. Our initial velocity is 0 because initially at rest. And then when it strikes on plate Q, the final velocity is 5.13 to the power of 6 meter per second. So I can determine the acceleration. So I can use the kinematic equations. So I can have v squared equal to u squared plus 2as. So we do the calculation. So the final speed is 5.13 to the power of 6 squared. Initial velocity is 0, 2a. So the distance traveled is 2 to the power of -2. So I'll get the acceleration will be around 6.58 to the power of 14 meter per second. So once I get the acceleration, I can find the electric force. So the mass of the electron can determine, the mass of the electron, you can get it from the list of constant 9.11 to the power of negative 31. So multiplied with the acceleration, 6.58 to the power of 14. So I'll get the electric force acting on the electron will be 6 to the power of negative 16 Newton. Then we solve question number 2.